So today we're going to look at 6.2. Okay, as I go through it, I'm not just going to throw the formulas up there. We're going to look at an example to kind of see where the formula comes from. Okay? So if you're on the test and you get stuck and you can't remember the shortcut, you're always going to be able to go back and do it out the long way if you had to. Okay, in this section, the first thing we're going to look at is what happens when you raise a power to another power. So it's like you've got something that has an exponent, right? And then you're going to put another exponent on it.
Oh, I hate those.
And there's a pattern that makes it very easy to figure out.
Exponent on an exponent? How the?
Yep.
Yeah, it's confusing.
Guys, again, just sit tight and pay attention. It's not going to be that bad, okay?
No, I didn't.
So in our first example, okay, I've got a cubed, and I'm going to take a cubed and raise it to the fourth power. Okay, a cubed to the fourth power. Okay, this is called a power of a power, when you raise a power to another power. Okay. So we're going to simplify that. Okay. How would you write this out? If I wanted to get rid of this exponent of 4, how would you represent a cubed to the fourth power? Think about what does an exponent mean?
Think about, guys, like we talked about yesterday. Yeah, maybe it's confusing some people because that's a letter. What if it was like 5? What if it was like 5 to the third power? What's that mean?
That you have 5 multiplied by itself 3 times.
Exactly. So how would you say that, Isaiah?
5 cubed.
5 times.
3.
No, 5 times 5 times 5, right? That's what it means. 5 times 5 times 5. All right? So, Ben, it says a to the third. What would that mean? I just said 5 to the third means 8 times 8 times 8. Good. Right.
So the first thing I want to do is I just want to write this without an exponent of 4. Okay, so how would you write that? What are you going to multiply by itself 4 times here?
A 3.
A to the third. Okay. If you're taking a cubed and you're raising it to the fourth power, it means a to the third multiplied by itself 4 times. Now, this is something we did yesterday. What do you get when you multiply a cubed by itself 4 times? You have the same base, and you're multiplying together.
So you know your base. You know your base is going to be what letter?
12.
The base is going to be, your base will be A, right? And then what's your exponent going to be? Isaiah, you just said 12, right?
Yay.
So all you're doing is you're adding up those exponents.
No, don't give me a thumbs up.
Notice what we really did, though. Okay, we got a to the 12th. What do you get if you multiply 3 times 4? 12. Okay, there's your pattern. When you have a power raised to another power, you're going to end up multiplying these numbers together. Okay, we're not going to have to write it out this long way each time. Okay, so let's try another one. What do you think x to the 5th squared would be? Final answer. X to the what?
X to the 10th power.
It's going to be x to the 10th power. Okay? Did everyone see what we did? When you have a power raised to another power, you're going to multiply the numbers together. Okay? So now we're adding in a new rule. Okay, another rule you got to know. How about r to the 6th cubed?
18. R18.
R to the 18th.
R to the 18th power. Yep, r to the 18th.
Oh my god.
Victoria, you go right till you get multiply. Yep.
Okay? Questions on that? All right. The shortcut's going to save us a lot of time because we don't want to have to write this out, r times r, 18 times. Okay, that'd be the long way to do it. Okay, so this is called a power of a power, or power raised to a power. If you have a base, and it has a power, and then you raise it to another power, what happened to my base? It stays the same. Okay, the base doesn't change. What did I do with my 2 exponents? M times n. I multiplied them. Okay, so to raise a power to a power, do exactly what Eli just said. Keep the base the same.
You guys have that. You guys have that on your sheet. Right?
Multiply
To raise
your
power to a
exponents.
power, you have that. So everything that's underlined is what you're writing on your sheet. You're writing your sheet to a power. You multiply the exponents and keep the base the same.
Yep, you should write that down.
So after it says to raise a power, you're going to write to a power, comma, you multiply the exponents and keep the base the same.
Can you make the letter bigger?
Yep.
Thank you. Maybe.
Okay, so these rules by themselves, the one we did yesterday, this one, the next one, they're all easy when you do them separate. Once you start putting all these rules in the same problem, that's where people start to get confused. Okay, so try to, if you don't understand the basic problems, ask one of us to explain it again. Okay? Okay, does everybody have that? Raise a power to a power, keep the base the same, multiply the exponents. Okay, so now in the first problem, the directions say simplify. Okay, when you see simplify, does that mean you're going to get a numerical answer? Or are you just going to combine what you can? Combine what you can. What word would it say if it wanted a numerical answer? Evaluate. We know we can't evaluate. They didn't give us a number for C to plug in. Okay, okay, what's C squared to the fifth?
So guys, on your sheet, make sure you put this on there, okay? On your note sheet, you want to put this.
Oh, Joe, what's C squared to the fifth?
2 times C.
Okay, what happens to your base when you raise a power to a power?
Oh, it becomes 7.
Let's go back.
Did you just say it
Okay.
becomes 7?
To raise a power to a power,
No.
keep the base.
Just like a power of times.
You guys, I got this. Don't worry, I can help. Okay. Keep the base the same and multiply the exponents.
Just what?
What's my base here?
C.
C. Keep the base the same.
Oh, God, man.
Multiply the exponents. 10.
Guys, make sure you put that on your note sheet, okay?
Okay, I see where you got 7. Okay, a lot of people make that mistake. Adding exponents as if you had something like this. Okay, that would be C to the 7th. Okay? Okay, any questions on that?
Can you start over here from now on?
Yeah.
Okay. How about example 1B? Okay, this is going to go on the sheet Mr. Roy is passing out right now.
7 to 30. Y, yeah, Y 30 to 30.
So y to the, I think, yeah, Isaiah just said it. Y to the what?
30.
Y to the 30th.
Well, I was saying 7 to 30, and then I was like, wait.
Okay, any questions on how he got 30? Just doing 3 times 10. Okay. Question, Victoria?
You're all set, man.
What's that?
Yeah, the only example that should be on your thing right now is the first one we did. That's it. The rest of these are going to be on the rest of the example ones. All right, are going to be on the front side of the sheet I just gave you. And when 2A comes up, you'll know. Because 2A is a little bit more challenging. We wanted you guys to have a more simpler one and then a more difficult one on your reference sheet. All right, so for now, the rest of these we're going to work on the example sheet. All right?
Justin. Trying to warn you. X cubed cubed.
Yeah.
What's that going to be?
No. X and I power.
Yes. X to the 9th. Okay, A to the 21st squared. Yeah. Look. 8 to the 42nd. These are the kind of problems. If you see these on the test, these should be quick. Shouldn't be spending a lot of time on these. Okay. X cubed to the 6th.
X to the 18th.
X, I heard a couple people say it. X to the 18th. Good. Okay. Any questions on the...
Which one are we on?
We just did all example 1.
It's to the front side of the example sheet.
Okay, so these are the ones that are basically one step.
Oh, I know how to do this!
All right, so the next rule we're going to look at, okay, guys, the next rule we're going to look at is when you have a product. Okay, you're multiplying two things together, like 2x, and you're cubing it.
No, guys, don't worry. You don't have to worry about writing this rule down or anything. All right, just pay attention.
Boy.
Question? Yes. What's up, Isaiah?
Oh, I wanted to check something.
All right, so now we're going to take a product and raise it to a power. Okay, this rule is called a power of a product. Power of a product. Because you have a product, two things are being multiplied, and you're going to raise it to a power. Okay. How would you write this out without an exponent of 3? What does 2x to the 3rd power mean to do?
Multiply.
2x times 2x times 2x. Okay, that's what it means. 2x times 2x times 2x. Okay. If you write it out the long way. Hopefully in a second you guys will see a shortcut. Okay. What's my constant in all three of those
3.
parentheses?
2.
2.
Whoa.
What's my variable? X.
I see a 3 right there.
So what I've done is I regrouped it. So you've got 2 times 2 times 2. Okay, we're going to figure that out in a second. And then x times x times x. We're going to figure that out. How could you write 2 times 2 times 2 shorter? 2 to the 3rd power. How about x times x times x?
X to the 3rd power.
X to the 3rd. And I think somebody said 2 cubed is 8. Okay, I want you to look at this and look at that. Basically, all you have to do when you have a product, take the first number, raise it to the power. Take the second letter, raise it to the power. That's all that happened. Each one of these got raised to that power. Okay? Let's try another one. Okay. What's the first thing that's going to get raised to the second power?
Writing this down.
If it helps, whatever helps you. It's up to you. I don't know. Personally, I like to see where the formula comes from, because if I forget it, I can always go back and say, wait a minute, I know another way to do it if I forget the formula on the test. Okay. So what are we going to do with the 4? Ben? Go ahead, Ben. We're going to take 4 and raise it to what power? Second. What about the x? Same thing. Okay. So you're raising the 4 to the second power, and you're raising the x to the second power. Okay. So if you can remember that, you can jump right to that step. 4 to the second, x to the second. What's 4 to the second?
8.
Not 4 times 2. 4 times 4.
16.
16. 4 to the second is 16. Okay. How about if I had, let's say, 5x squared? Who can tell me my first step to doing that? Okay, you could write 5x times 5x. You could write it that way.
You take the 5 and you put the 2 above it.
Yeah. Okay, it's
5 to the second.
5. Yeah, it's 5 to the second, and then x to the second. Okay, I would say when we're doing it, most people are just going to jump right to this step. Take and raise 5 to the second, raise x to the second. And then if there's something you can do out, do it. What's 5 to the second? 20, 25.
Wait, are we timing the letters together?
Yep. We times these two letters together to get x squared.
I'm doing the 5 and 2.
So 5 times 5 is 25.
Oh, that's.
Yep.
5 times 2.
Okay, yep, that's an exponent of 2. Okay, any other questions on that? So try to remember where the formula comes from. So if you forget it, you have some way to still answer the question.
Mr. Roy.
All right, now guys, understand that. Just a couple things. All right. I know for some of you guys are like, it's an easy week. We've done this stuff before. That's fine.
Yeah, but we haven't done
Yeah.
That's completely fine. But the thing is this: it's unfortunate that some people have to hear this, but the people that continue to make noise and do the things they're really not supposed to be doing are the ones that are, unfortunately, in jeopardy of being here during the summer. I'm not going to single out any names. I'm not that kind of a person. But you guys, people that you know who you are, and you guys know those people know they have to have a good fourth quarter to be able to not be here during the summer. And remember, even if you're like, oh, I'm not going to summer school, I'm not going to do that. Well, guess what? You won't be a sophomore next year. So we got this. This is just a little extension what we were talking about. All right. It's just when you have that exponent outside and you have two terms on the inside. And when we go over the example that's on your that's going to go on your note sheet. You'll see. All right. So this says to find the power of a product, raise each factor to the power. And it might be a little bit difficult to understand right now, but let me explain it in the next example and you'll see. All right? So, next slide. 2A, all right? This is going to go on your note sheet. The sheet we had you guys find, the one we wrote on yesterday with the boxes on it. We already put one example on there. All right? This is going to be example 2A has the date right on there, 6.2/5/2015. So, sometimes when Mr. Hager does it one way, we've done this a lot this year, Mr. Hager does it one way, and some people are like, yeah, I got that, no problem, I'm on it. And then I've done stuff where I've explained it a different way. So this is just a different, I'm not saying you have to do it this way, it's just another way to think about it, that's all I'm saying. I think of it like this, and I've had other kids that have thought about it this way in the past. You have the parentheses, right? And you have a number on the outside. Is there something else? I mean, usually it's a big number up here, and usually it's in the front of the problem. But haven't we seen something like that quite a bit this year and throughout all your school? What's that called, Eli? Who said it? Chelsea, are you going to say it? What is it? Yeah, distributive property, right? I think of this when I have my exponent on the outside and I have my terms on the inside. I think of it as almost like the backwards distributive property. Because it's not in the front, it's on this side. I think of it like the backwards distributive property. But remember, like we said yesterday, we have to, break if we're thinking of it that way, like I said, we're going to do it tomorrow too. Break your stuff up. Break up your letters from your numbers. All right, break them up so you know. And then, that's going to go to this. That's going to go to this. All right. So that will equal. I'm not saying we have to do all the math right now. We don't have to figure out. All I want to know is I'm doing like that first part. All right. When I do that, what am I going to get? Anybody know? Anybody raising their hand? What am I going to do that first part? I'll get -4. What? To the third. And then what about that C? C to the third. -4 to the third, C to the third. With parentheses.
Not the -4.
Huh? Oh, sorry, Mr. Hager. Mr. Hager wants parentheses around that. Like he's been saying that -4 is a lot. That -4 is a lot different if you didn't have the parentheses. Remember he showed you yesterday with the calculator? He did it one way, he did it another way, you'll get a different answer. So if you have that whole number, all right, make sure you put the parentheses around it.
So
Okay?
that's how a lot of you guys are gonna do it. You're just gonna type it in, hit enter, and write down whatever the calculator gives you.
So, we have that, right? Now, am I done?
No.
What do I have to do now? Who can tell me by raising their hand? What do I have to do now? Anybody know? Simplify, all right? I agree with you, Ryan, but how do I simplify? What do I have to do to simplify? Victoria,
Add 3.
Multiply 4 by itself 3 times.
is it 4 though? Negative 4, right? So I'm just going to draw a little arrow here so you guys can see it. It's negative 4 times negative 4 times negative 4. All right? Negative 4 times negative 4 is what?
Negative 6, positive 16.
Positive 16, right? 16 times, who's got a calculator up there? 16 times negative 4.
64.
Negative 64. Good. So I simplified this, right? Negative 64, and then c to the third. That's my final answer right there. Negative 64, c to the third. Guys, I don't want you to get too caught up in this, but it's a good way to check yourself. When we have the big number in this, right? What do we call the big number? The what? Talked about it yesterday. Starts with a B. We call it the what? The base, right? We call it the base. The big number is the base. What's the little number called? Starts with an E. Huh? No. What's the E? What's this little number called? What do we call these? Exponents, right? We have the base and we have the exponent, right? Our base is negative, right? Our base is negative. 3. When you were back in maybe like elementary school, you talked about odd and even numbers, right? Is 3 an odd or an even number? Odd, right? Here's one little trick to check yourself when you get these. All right? If you have a negative base and an odd exponent, your answer is going to be negative. All right? If you have a negative base and an even exponent, your answer is going to be positive. That's one way to check yourself. All right? It's like this. You're like, okay, I know 3 is odd. And I got a negative base. My answer better be negative. All right? I got a 2 here, and my base is negative. My answer better be positive. That's one way to I'm not asking you to memorize it. It's just one way to check yourself. Okay? Next one. All right? 2b. Now, I'm going to get, when I do this, when I simplify, right? The negative x and the y squared are, the negative x and the y squared are separate, right? So I'm going to bring the 4 in here. I'm going to bring the 4 in there. What am I going to get from Austin? What am I going to get from negative x? It'll be negative x. What's the exponent going to be? Well, there's a 1 here. I agree because there's no exponent there. But when I bring the fourth power in, what would I get? So what would I get? Negative x to the 4th, right? Negative x to the 4th. Now, what about my y squared? What's that going to become? Anybody know? What's the exponent going to be for y squared? 8. Y squared to the 8th.
Joy, can you do that in 2 steps? Just to show them.
Show them this. Show.
Yeah, just the y squared part.
So we're going to get negative x to the 4th. Then we're going to get, I'm going to put the y with the 2 times 4.
Yeah, y squared to the 4th.
Y squared times 4, right, to the 4th. All right? I'm just multiplying those two things together, okay? So I'll get negative x to the 4th, y to the 8th. I'm just bringing that number in on the outside. Oh, sorry, parentheses around this, right, Mr. Hager?
So remember, you get a negative to an even power. You're going to go by that
Yep.
odd rule.
Yep.
So what's going to happen to that?
7 to the x. Remember, x is negative, right? What kind of a number?
Even between.
Exactly. So it'll be x to the 4th, y to the 8th.
And that
All right.
negative should be grouped inside that parenthesis, okay? You guys
Negative will be inside. That's all. So there's no, if you have a negative base, even exponent, positive answer. Negative base, odd exponent, negative answer. All right, that's the biggest thing. Even if you make a mistake with where your negative sign is and stuff like that, as long as you can kind of remember that rule, it's helpful. Okay?
Let me show you guys a very similar problem, but very important difference. What's the difference there? Yeah. So this time when you do it, that negative is just going to hang around in front all day. It's not part of what's inside the parentheses. So when you do this one, you're going to get this. 2 times 4. What's the difference between this problem and the one Mr. Roy just did in the final answer? The final answer, what's the difference going to be?
My answer was what? Positive. Mr. Hager's going to be what? Negative. Like he was saying, because he's showing you guys, he put that negative on the outside of the parentheses, like he said. It's just going to hang out around. It's just going to hang out there all day. It's not going to be part. It's not part of the problem. You just bring it in.
And it is possible. You could have one like that on the test. So make sure you understand that.
Understand the difference.
that rule. Questions on that?
So that
For which problem?
the one I did is positive. Mr. Hager was just showing you if this negative was on the outside, this is what you get. He's just showing you the difference. If the negative is included in the problem, all right, chances are you're probably going to get a positive result. If the negative is on the outside, you're probably going to get a negative result, depending on what's there.
So it's inside positive, outside negative.
Depending on what else is in the problem. All right? Depends.
This isn't clear, is it? I can tell. Some people are confused. So, the difference here, if you want to go by Mr. Roy's rule, when the negative is on the inside, you can use that even-odd rule, if that makes sense. When the negative is on the outside, it just hangs out there. You don't use any rule. You just keep copying it down for the whole problem.
Just keep bringing it in.
I don't know if that makes it simple. Okay? Does that help?
I guess.
And again, don't get too. I mean, if we're gonna put something like that in the test, like we've done all year, we're gonna let you guys know in advance. We're gonna give you questions like that to practice, so you're ready in advance. We're not just gonna throw it at you.
Okay, here's one like we were just saying. You've got a negative on the outside. Okay? So this negative has nothing to do with this exponent. It's on the outside. Okay? So what is going to get raised to the second power here? Not the negative 4x. That's just hanging out in front. What's going to get raised to the second power? The 5. What else? And the x, yeah, that's going to become x to the 6th.
So do you multiply the negative 4 and the 5 first, and then square it?
Okay, first thing you do is you raise the 5 to the second power,
Oh,
and then you raise x cubed to the second power. First step.
that's equal to.
Questions on that first step?
No.
Okay, now your next step, simplify what you can. You got negative 4 times x. Let's do out, Travis. What's 5 squared?
5 squared is
25. Good. And then I think Shelby already said this, x to the 3 times 2 is x to the 6th. Okay, now, anything here that you can multiply together? Anybody see some like terms?
X's.
Yeah, we can do the x's.
4 and 25.
What's that going to be? X to the
Negative 200.
7th.
Oh,
Okay, so you guys, I think you're talking about two different things. Isaiah's talking about multiplying negative 4 times 25, and Eli's multiplying the x's. We got to do both eventually. So we have x to the 7th. What's my constant?
negative 220.
Negative 4 times 25?
220. Wait, no. What's.
Negative 100. Okay, so notice this negative was in front. It basically stayed for the whole problem. If that negative was inside, it would have disappeared. Okay, think of that rule Mr. Roy just showed you. Negative on the inside to an even power, negative disappears. Okay, any question on that one? Okay, so notice here, you had a 5 and an x cubed. Both get raised to the second. Okay, you had an x and a y squared. Both got raised to the fourth. Okay, you can use the same rule here. If you've got 2 things inside, 3 things, 5 things, 10 things. Doesn't matter how many things. Every one of these is going to get raised to the 5th. Okay, all 3. Okay, what's the first thing that gets raised to the 5th power? The negative 2, and what do I want to make sure I do with that negative 2? How do I want to write it?
2.
Do I just want to put this?
Negative 2. Yeah, you could. A.
What do I always want to make sure I put around that number? Parentheses. That negative and the 2, they're both being raised to the 5th. Okay, so you're going to use that rule we just learned. Negative to an odd power. Okay. Okay. Next thing. A to the what? Yep. A to the 20th. Okay. Last thing. B to the 30th. Okay, so the A, that's done. Okay, B, that's done. Negative 2 to the 5th. Okay. What kind of number is that going to be? The rule that you guys just learned. What's the rule Mr. Rice said? He didn't say this was going to be positive. Negative to an odd power. Okay, think about, let's write it out.
Oh my God.
Forgetting about the number, just look what happens. What's a negative times a negative? So when you multiply the first 2, that's a positive. What's another negative times another negative? That's another positive. Okay. What are you left with at the end? A negative. Okay. What's a positive times a positive? Positive times positive is positive. What's a positive times a negative? Negative. So the rule that you just learned, if you have a negative number raised to an odd, the answer will always be negative. Okay? If it's a negative number raised to an even, like if you had another negative 2 on the end here, then you'd have negative times negative is positive, negative times negative is positive, negative times negative would have been positive. You would have had all positives. Okay? All right, so we know it's going to be negative. Anybody know what 2 to the 5th power is? Let's go, if you're not sure. Yeah? Yeah, it is negative 32.
Wait, what?
Okay. 2 times 2 is 4.
Yeah, and then
Double it again, you get
negative 8.
negative 8. Double it again, negative 16. Double it one more time. Negative 32. Okay, if you can't do that in your head, that's fine. Type it in on your calculator. Just type it in on your calculator. Okay, this one. Okay, guys, I need you to pay attention, okay? I know we're almost done, and we have I think 2 examples left.
Actually, we have 1.
1 example left?
Yeah.
Okay. First thing you want to handle is this exponent of 2. Okay. Who can tell me what's going to get raised to the 2nd power?
7. 4.
The 4. And what else?
7.
The y to the 7th. Okay. Is that 2 going to affect this negative y squared?
Yeah, yes.
So this is inside the parentheses with everything?
No,
No.
but it's
Nope.
That's going to stay.
It's just going to stay.
what I meant.
Okay, we might have to deal with it in a few minutes.
Yeah.
But this 2 doesn't affect it at all. Okay, so we have y squared times 4 to what power? 4 to the second. How about y to what power? Y to the 14th. Okay. This negative, just going to hang out in front. Nothing's going to happen to it. What about 4 squared? We can do that out.
Wait.
16. So we dealt with the well, I don't want to cross it out so you can still read it, but we dealt with the negative,
20
dealt with the 4 squared,
y
2 things left.
y over 20 over y.
Okay, what do you do with these exponents when you have the same base? You don't multiply them,
Yes.
add them.
No, it's 16.
Okay, so be careful with those rules. The only time you multiply exponents is when you have a power to another power. Otherwise, you add them. Okay?
Where
Hey guys, F didn't make it on that, that's okay. Why don't you guys just do,
Two days in a row, Mr.
I know, I was trying to give you a few less examples, I said. I was thinking.
Do they have G?
Guys, take a few minutes and do these ones on your own. We'll come around and check them.
What?
There's more.
So, guys, in this problem, don't worry about the 5 just yet.
Okay.
Guys, remember the conversation I had with you? I took 3 minutes out of class time to talk about that, and I wasn't kidding. Thank you. All right. So, don't worry about this 5 just yet. Okay? I want you to remember what's on the inside. I have 3 things on the inside of that problem. I have 3 things. What's one of them, Marcus?
The base is 3.
I have 3, right? 3 is one thing. Marcus, I know you know, but bring your hand out for that.
Oh my God.
What's another thing that's in there?
A C2.
C squared, right? Ryan, what's the last? So I have the 3, I have the C squared. What's the last thing on the inside of that parentheses? The D, just the D. But there's no exponent. What's it mean? What do I put? Well, D to the first. But now, we haven't got to that part yet. Alright, so D1. Now, this is where some of you guys are having a hard time. Remember, treat each of these things separately. Treat each constant, which is a number, treat the constant, treat the variable, and if it has an exponent to the right, that belongs with it. So C to the second, D to the first. Treat each of those things separately. Right? Some of you guys aren't applying, you're not doing that power of a power rule. You're not bringing in all 3 things. So I'm going to bring it into this, I'm bringing it into this, I'm bringing it into that. So what is my, Justin, what's my 3 going to become?
2.
Don't listen to Eli. Be your own person. I know you know this stuff. What did I say? What did we say? If there's a number on the outside of the parentheses, I multiply it to the inside. So 3 is going to become what? 3 to the 5th. Remember, if there's no number there, you're just going to put a 1.
Oh, I thought the 3 was
3. Don't worry about doing that yet. There's no, you're doing, your exponent here is 1, your exponent on the outside is 5. 5 times 1. All we're doing right now is worrying about the little numbers, the exponents. It's all changing right now. Travis, what's my C going to become?
Your C, it's going to become
C to the 10th. Good. Everybody with me there?
N and D.
All I'm doing is dealing with my exponents right now. So I got C to the 10th.
Then D to the 5th.
And then D to the 5th, because there's no exponent there, so we know it's 1. It'll be D to the 5th. All right? One more thing I have to do. One more thing. That's why on Friday, or maybe even for the rest of the week, it's important that you bring your calculator. All right? Go ahead, Isaiah.
multiply 3 by itself 5 times.
Multiply 3 by itself 5 times, which will give me, if you have a calculator, everybody do it, 243. 243, and then what's left?
The C10.
C10, D5. There's your final answer. 243, C to the 10th, D to the 5th. All right? All right, now this one. And guys, this one's tricky, right? So I'd suggest paying attention. Justin, stop touching people. All right, so for this one, Laura, inside of my parentheses, what are the two things? The 2 and the Y4. Excellent. All right? Travis, not funny. It gets old after a while, man. The noises and the stuff like that, it gets old. All right? If you know what you're doing, you're not doing too good of a job of showing it. All right? So, I'm going to bring this. I'm going to bring this in. All right, that's fine. Done. All right, so we got, like we said, we're gonna do that, like that backwards distributive property, like I talked about. All we're worried about right now is just the little numbers, right? The exponents. The 4 here. Like we said, if there's no exponent, we're just gonna put a 1. Yeah, we're just gonna put a 1. We're just gonna put a 1 there. We're just gonna put a 1 there, and then we should be in good shape. So yeah, like I said, once we put that 1 there, right, we'll be in good shape. And then we're just going to multiply. Like I said, treat both things separately. The constant from the variable, and then the exponent to the right always belongs to that variable or that constant. So I got 2, and I got 1 times 6, and I got y4 times 6. All right, I'm just going to keep going this way for the lack of space. Right? I still got that negative here on the outside, like we said in earlier examples. That's just going to kind of hang out. It's not on the inside of the parentheses. It's just going to hang out. All right, so I get 2, and then I get still inside the parentheses, and I got 1 times 6 is 6. And then I got y, and then 4 times 6 is 24. And this 2 to the 6th power will give me, if I punch up on a calculator, it says 2 to the 6 is 64. Like we said for the test on Friday, you can have your calculator with you. So I got 64, y to the 24th. Like we said, we got that negative on the outside. That's just going to hang out. We're just going to bring it down. And there's my final answer. Negative 64, y to the 24th. All right? And then the homework tonight, I think it's like 10 questions. It's going to be a worksheet on 6.2.